So when we look at the function y equals sine theta, we have this curve, and it's going to be based on the four quadrants. Okay, so we can break this down to the four quadrants. And the period of this is 2 pi. So from start to finish, we have a period of 2 pi. So if I have my starting point here to my ending point here, that period is 2 pi. And we denote the period with a t. Okay, so t is our period. The other part that we want to take a look at here is something called the amplitude. So this is new terminology. The amplitude is this distance from the center to the vertex. So the amplitude of a regular sine function, the amplitude is equal to 1. So it goes 1 up from that and 1 down. So amplitude is a distance. So it's not a coordinate, so it doesn't have any direction to it. So we have an amplitude of 1 up, amplitude of 1 down. The other things that we want to make note of when we graph this are the boundaries of the quadrants. So I've kind of highlighted them here. We're going to use those green points as reference coordinates. So it starts at 0, 0. That happens to be our one of the intercepts. It goes up to 90 degrees, or pi over 2, to y equals 1. So that's going to be our max, and we're going to use that as a reference point. It also goes down, all the way down to -1. So that -1 also is a reference point, and that's an important reference point. And then we have our 0. So 0 is going to be the middle, which is pi and 2 pi. Okay, and again, this then repeats itself. So those reference coordinates are going to be important for us to keep track of when we're doing our transformations on this. When we look at the cosine graph, okay, how do we generate the cosine graph? Well, again, we can go back to the unit circle and see what happens as we increase our angle from 0 to 2 pi. So for quadrant 1, as we rotate from 0 all the way to 90 degrees, or pi over 2, what's happening is since cosine is an x position, we start with a position of x equals +1, and we go all the way to a position of x equals 0. So that's going to represent quadrant 1. And so this position here, the quadrant position, is pi over 2. In quadrant 2, as we start at an x position of 0, and as we rotate around the circle, we're going into the negative x positioning all the way to -1. So we start at 0, go all the way to -1. For quadrant 3, we're going to start at -1, and as we rotate, we're going to go back to an x positioning of 0, and that's what's going to happen here, -1 all the way back up to 0. And then finally, as we go back to 2 pi, goes up to +1 x position. Okay, so because cosine is to do with the x positioning, we have a slightly different graph. Okay, same shape, but slightly different. So we start at 1, we decrease to 0 in the quadrant 1, we go all the way to -1 in the y values at pi. Okay, this is the next quadrant, or 3 pi over 2, and then back to 2 pi. And again, the period is going to be pi. We have our reference points. In this case, are going to be the middle line values. So pi over 2, 3 pi over 2 are zeros. And then our max and min points. Our max points are going to be at 0, 1. And the minimum point is going to be at pi -1. And then again, we go back to the max at 2 pi and 1. So those parts are important to recognize. Again, the new part that we're looking at is the amplitude. And the amplitude is the distance from the center all the way to one of the vertex, either up or down. And again, the amplitude is just an absolute value. It doesn't have a positive or negative, so the amplitude is equal to 1. Okay, so the distance from the middle to the top or the middle to the bottom is the amplitude. So this is what our cosine function looks like. And again, if we compare it to the sine function, it's slightly different. The shape is generally the same. The quadrant shapes are the same, but where it starts is a little bit different. So we have a slightly different looking graph for the period from 0 to 2 pi. Again, there's 4-part symmetry to this because of the way we go around the circle, and each quadrant is symmetrical to the other. So every quadrant, although it's in different orientation, the shapes of the function parts of the quadrants are the same.